Okay. Thank you, Linda. And thanks everybody for joining. I'm excited to be here to talk about aseptic filling and risk elimination today in this Tech Tuesday. So let me kind of get started here. So a bit about myself. I think Linda did a great job introducing me there. I've been working in pharmaceuticals for 8 or 9 years now. I started at a generics manufacturing facility right out of university. So I kind of got to see the entire process with my very first job, really, from dispensing, solution prep, filling, packaging, and visual inspection. I got a little bit of everything there. For the past 3 to 4 years, I've been really focusing on filling lines and the aseptic filling process, mostly with integrated isolators on that one. So just a bit about me there. Let me find my mouse. All right. Okay, so for today, we're going to focus on mainly just the aseptic filling process at the filling machine itself. So there's a lot that goes into the process, but we'll mostly just talk about what happens at the filling machine. So we'll define, what the aseptic process is, what the sources of contamination are. We'll try to define that risk and then look at how to control that risk. And then we'll look at the aseptic filling process over the years and where it's headed into the future. So for this presentation, I might kind of speed through a few slides or skip over a few things. I want to make sure we have plenty of time at the end to maybe have more of an open discussion or a Q&A session. And we can use Klaxoon for that. So if you guys are not familiar with Klaxoon, it's a great tool. So what you can do, so Linda posted the link. Let me find my laser pointer. There it is. Laser. So this link is in the chat. So if you want to use your PC, you can access this link. It should pull up in Chrome. And you can type, I think you type your name in first or type this code in. So you have to have this access code to get into the Klaxoon session. And if you want to use your phone, you can scan this QR code and use your phone. It's an app. You can download the app really quick, and it's the same access code to get into it. So that's in the chat for Zoom, and let me pull it up and see if we got. So this is what you will see when you get into the Klaxoon session. So it's just a very simple whiteboard. So we have a quick little poll here on the left-hand side, 4 questions. Do you have any filling line experience? Do you know what a filling line is? Have you worked on one? Are you, an expert? Doesn't have to go into that detail, just kind of yes, no. What type of filling lines are you familiar with? Have you had any sterility issues on those lines? And then we can give a brief description of what that is. So for this poll, you can just double click onto the item and it should pop up. Can everybody see that? And then you can vote yes or no. And then you can also add a comment too. If you'd like to add a comment, you can say maybe, if you're not sure. And you can post that comment as well. So and then for the types, sorry, a couple people are answering here. We have 2 votes. One of those is mine. So maybe give it a couple minutes. I'll let people get logged in here, and then we can kind of see what the audience has experience-wise so far. So if you have any issues, let me know. You can speak up or type in the Zoom chat. And then as we go along through the presentation, I'll have this open and I'll keep an eye on the question board here. So if you want to post a question, all you have to do is click this little plus icon down here at the bottom, and type your question. And then you can post it, send it, and you can place it anywhere on the board. So, and it's just like a sticky note. So I'll keep an eye on this. So as notes pop up, I can, and you can move stuff around too. I think we probably should have locked it, but that's fine. We'll see what we can do here. Yeah, so I think everybody has access to move stuff around, so maybe we'll try to be a little careful on that one. Delete that. There we go. Okay. Let's see how many votes we got here. So 4 votes. So RABs with glove ports, isolators. Sounds okay. I'll get started on the presentation. Again, I'll keep an eye on this. I can flash it up kind of as we go. And if you have any questions, feel free to use Klaxoon and just drop the sticky note on the questions here. Or you can also use the Zoom chat, and I'll try to keep an eye on that as well. So let me drag this over. Okay. All right. Okay, so getting started, we'll define the aseptic filling process. So at the most basic level, the aseptic filling process is defined as the process and packaging of a sterile product into sterilized containers, followed by sealing with a sterilized enclosure in a way that prevents microbial contamination. So everything is sterilized separately, and they all come together at what will be called the critical zone. So the liquid, the media, the containers, the equipment, the sealing components, they all come together during the filling process, and that is what will be the critical zone. And they're all sterilized separately, and then assembled in a sterile fashion as well. So the assurance of sterility relies on control of microcontaminants from multiple sources across the entire process. So the entire manufacturing process is quite complex. There's the equipment washing, sterilization, component washing, sterilization, transfer to the filling room, transfer into the filling line. And then for the filling line, you also have the clean room design, HVAC design, and the filling machine design itself. So all of these impact the control you have on the sterility of your process. So each individual process has to be assessed, controlled, and monitored throughout the entire life cycle of the process. And of course, throughout the entire process, we have operator involvement. So some processes are very operator heavy, lots of manual activities. Nowadays, most of these are moving towards more of an automated type process, but again, there's everywhere in between when it comes to operator involvement. Okay. So the more manual a process is, the more an operator is involved. And the more the operator is involved, the higher risk of contamination we have. So I'm sure it's well known to everybody in the session today that the operator is always the biggest risk of contamination in the process. Okay. So as far as risk when it comes to aseptic filling, so the risk is equal to the probability of harm multiplied by the severity of that harm. So how likely an event is to occur multiplied by the impact it will have. So for aseptically filled products, the severity is very easy to define. The severity is always equal to high. So when we're talking about the aseptic filling process, we are downstream of all sterilization techniques. So once we get to the filling machine, to the critical zone, there is no downstream sterilization. There's no autoclave. We throw the vials in. That would be a TS product. So we have to ensure that the aseptic filling process is completed in a sterile way that does not allow microbe contamination as it goes. So we need to control the risk, right? So the severity of the risk is always high. So, but the one thing we can do is we can control the probability. So we have to reduce the likelihood of a contamination occurring. So, like I said, operators are the biggest risk of contamination for the aseptic filling process. And humans will always shed microbes, and the presence of microbes during an aseptic intervention is considered unavoidable. So that's kind of the key take from here is whenever operators are involved in the aseptic process, it is assumed they will contaminate the process 100%. So to reduce the risk, operators go through aseptic gowning training, qualification, and a continuous requalification cycle. I'm sure a lot of us here have been aseptically trained. It's a long, tedious process. Some people are really good at it. Some people take time to learn the aseptic gowning technique. I've seen people who can do it very quickly, and their plates are always clean. They never have a hit. And I've seen people who are very, very sloppy, and their plates are also clean. So aseptic gowning is required. It is necessary to remove the risk of some of the risk of the contamination from the operator, but it's not 100%, and it's not the best way we can go about removing the contamination from the operator. Okay, so the best way to control the risk is to remove the operator from the aseptic filling process completely. So we just get them out of there. Obviously, this is much easier said than done, but let's look at how it's kind of evolved over the past few years in the pharma industry. I see we have a couple questions in the chat. This is more about autoclave sterilization. I'm going to save that one to the end. I'm not an autoclave sterilization expert, but Simone is, and it looks like he's replying a few answers here. But we can talk about that question maybe at the end, as it doesn't really fit too much with what we're talking about now, but we can definitely address it at the end here. Okay, so coming back to the filling line itself. So starting way back in the day, we had open bench tops, like a very lab type setup where operators and pipettes. This is no longer really seen anywhere in the industry except for R&D. So moving up the line to a clean room. This is where you have the filling machine setting inside a clean room with 100% HEPA coverage, no physical barriers separating the operator from the critical zone. And we'll look at examples of each of these as we go. Moving up a bit, we have RABs, which are widely used throughout the industry, and there are many different types and styles of RABs. We have open labs, closed, active, passive, with gloves, without gloves, and every combination in between. And every company has kind of a line that's been modified many times over the years to create a new style of RABs. But the common thing with all RABs line is they provide a physical barrier between the operator and the critical zone, which is not provided in the classic clean room type design. So now for present day, isolators are widely accepted as the most desirable type of filling machine. Many reasons for this, which include the integrated decontamination cycles, the elimination of the need for a grade A/B room, and generally the isolators are smaller machines, more flexible, which are ideal for the biological and gene therapy treatments, which are starting to become more and more readily over the years. Okay, so now we'll take a look a bit more detail here. So In this photo, you can see this is the classic clean room or conventional clean room design. So no physical barrier stopping the operators from accessing the critical zone. So over here, the critical zone would be everything inside this room. Generally, they just have laminar flow curtains, and that's just to help promote the laminar flow from the HEPAs to the product path. Again, nothing really stopping the operators from reaching over the vials, breaking first air, not a lot of control in this environment. So you can see, breaking down the concept a little bit more, we have the grade A room. The airflow is provided by the room HEPAs, and there's no barrier separating the operator from the critical zone. It's just generally the laminar flow curtains. Okay, so the main reason we want to separate the operator from the critical zone is due to interventions. So per FDA requirements, all aseptic operations in a critical zone shall have dynamic smoke studies performed to show the process is designed to prevent contamination. So with these operators that are working in the aseptic filling lines, they have to be a part of the qualification process of that line. So you have to identify the type of intervention that is required. Say it's a toppled vial or a jam stopper track, and then you have to identify the solution to that issue, and that would be the intervention. So these interventions need to be described in SOPs, and they need to be tested via smoke studies to ensure they do not impact the sterility of the product. So the operator has to perform these interventions with the smoke studies to ensure they still have laminar flow flowing down and away from the machine. So with the conventional clean room, it's very difficult to control the operator's impact on the airflow. Operators are all different shapes and sizes. They move differently. Right-handed, left-handed, they're all going to react differently when they're inside the critical zone. So once they're inside the critical zone, it's very difficult to control what happens, very difficult to qualify, and very difficult to justify that it is sterile after the intervention is complete. So is a conventional clean room setup considered GMP by today's regulations? Most people would say no at this time. So most of these conventional clean rooms have moves up into a RABS line. So RABS stands for Restricted Access Barrier System. And the exact definition is an aseptic processing system that provides an enclosed but not closed environment meeting grade A conditions, utilizing a rigid wall enclosure, air overspill to separate its interior from surrounding environment. So basically you have air provided to the line and a physical door that separates the operator from the process. Okay, we have a question here on Klaxon. Let me just double check what this is. Okay, the question is about continuous manufacturing. So actually, maybe let's hold that one to the end. That could be a longer conversation. We can hold that one to the end. That's fine. Okay. So just a few types of RABs. Here we're looking at a passive RAB system. So a passive RABs uses the HVAC provided by the room. So we have the room HVAC system and the HEPAs installed on the ceiling. And that's what's used to maintain the pressure cascade and air overspill for the RAB system. So the size of the critical zone of the RABS line is much smaller than the size of the critical zone compared to the conventional clean room. So we added the doors. The doors are closer to the machine parts. So the critical zone is smaller. So for a RABS line, when we look at the interventions, same as we did for the conventional clean room, there's much more control over how an operator can impact the line. So the same intervention, say a toppled vial, would be handled via the RABs would be via the SOP. Operator places right hand in glove port number 1, uses the forceps from door number 2 to remove the vial, drop the vial into the catch pan, replace the forceps, inspect the glove, remove the right hand from glove port number 1. So that type of intervention is much better controlled for every time an operator performs it, and also from operator to operator. And then you can perform the smoke studies, and the operators can go through their operator qualification with a lot more strict instructions as far as how to perform these interventions. So here's a photo of one of the lines we've looked at in previous projects. So you can see this is a passive RABS with no gloves. So the example I just gave of an intervention obviously had a glove port. For this one, the same type of intervention would be operator opens door number 1, uses forceps from wherever, and then closes the door. So gloves versus no gloves is always a big debate. As long as you can maintain the positive pressure cascade of the RABS line when the door is open, generally it's acceptable. But you have to prove that in the smoke study to show that the flow is down and out of the line, even with the door open for an extended period of time, with the operator working in that area. So in active RABs, so the difference from passive to active is the machine has its own air supply. So it usually has an LAF, a laminar flow system that provides air specifically for the inside of the RABs. This will help out the pressure cascade a little bit. Generally, you can have a positive pressure to ensure the airflow is down and out of the RABs, a bit better than using the room HVAC design. So again, the size of the critical zone is slightly smaller. The HEPAs are slightly closer, and the smoke studies and interventions would be handled very similar to the other ones here. So we won't get into that. So yeah, just a picture here. This would be quite a big RABS line. So each section of the machine has its own laminar flow system on it. And then this one also has glove ports here. So you can see the air would come all the way down to the bottom, and it would exit the machine through the bottom. As the RABS system is not 100% sealed, it will have small gaps in the doors, and then an area for the air to escape at the bottom of the machine, or at least below the product path. Sometimes it's at the bottom, sometimes it's a little bit higher. Okay. So coming to present day, isolators are the most widely accepted as the desirable type of filling machine. Again, there's a lot of reasons behind this. You don't have to have a grade A, B room any longer. You can place the isolator in a grade C background room. Obviously, it saves a lot of operating costs, installation costs with HEPA filters, all that type of stuff. Much easier to maintain. But I mean, the main reason for isolators are desirable is the increased separation of the process from the operator. So they're very similar to RABs, and generally there is a barrier, and it will have a glove port. But unlike a RABs, if for some reason you cannot correct the issue by using the glove port, you cannot open an isolator up. For a RABs, you can always open the RABs door, even if it has gloves, and fix something. For isolator, the interior of the isolator is sterilized with a decontamination cycle, and then once that is complete, you have to complete the batch before opening the isolator up to the background. Okay, so just a quick look at a few types of isolators. So some isolators can be designed to exchange air with the room. So this would be the grade C or D background room here. Then you would have a set of filters that would exchange air with the room, and they would maintain a positive pressure within the isolator itself. It would recycle its air provide the laminar flow, and then in order to maintain pressure, exchange air with the room here. So some advantages of this would be it's much easier to install this type of isolator in your facility. You do not have to cater specific HVAC for the isolator itself. You just drop it in the middle of the room. It balances itself with the room it's in, and that's it. As far as the drawbacks, the decontamination cycle will take a little bit longer, as you have to break down the H2O2 prior to running the line. So you'll have to run it over a catalyst, which breaks down the H2O2 into oxygen and water. And this generally takes a few hours, depending on the size of the isolator itself. The other main type of isolator would be an isolator that is supplied from the house HVAC system. So they have a supply and a return. And again, it would modulate valves to control and the airflow to the isolator. But again, this would be a bit more complex to design and install, a bit more expensive, as you would need some sort of AHU to supply the air to the isolator. But depending on the product, it may need to be separated from personnel for safety reasons, or for whatever it is. When it comes to the decontamination cycle, these would be a bit faster in the aeration phase, as you could just exhaust the H2O2 rich environment completely out of the system and not have to wait for it to break down over a catalyst. Okay, so that's basically all the types of machines we'll talk about. Next, we'll kind of look at how to transfer components in and out of these machines. So once we have the machine in a sterile state, we still have to introduce product, introduce vials or carpejects, syringes, whatever you're filling. I'll mostly say vials for this presentation here. Stoppers and whatever other type of sealing system you're using. So we do have a sterile environment here after the decontamination cycle. But if we go back to the definition of aseptic processing, it's where sterile liquid is combined with sterile components and sealed with a sterile stopper in a sterile environment. So everything is sterilized prior to being introduced to the isolator or RABS line itself. So for a closed type of isolator, generally you'd have the vial washing, then you would go through a sterilization depyridization tunnel. This tunnel would run at whatever temperature to ensure that the vials are sterilized as they enter in to the machine itself. And that would also sterilize the air, the environment, as it's HEPA filtered and laminar flow going into the vials here. On the outfeed, most times they go into a lyophilizer. So this lyophilizer can be sterilized with the filling machine, depending on design and size and location, or it can be a sterile transfer directly to the lyo. Once the batch is in the lyo, you close the lyo door, and then it comes out the other side once it's stoppered. So for sterile stoppers and sterile bulk product, a common technique for passing these items into the enclosure, whether it's RABS or isolator at this stage, is using an RTP, a rapid transfer port. So we'll look at those a little more detail. So you can see you can transfer almost anything into an isolator with an RTP, plungers, stoppers, caps. They can also be used to transfer the sterile product in, to transfer microplates. If you have an RTP port, you can pretty much transfer anything in and out, as long as whatever you're transferring in is sterilized. And this ensures an aseptic transfer of components inside your machine. This would be how the product would come in. So your set of sterilizing filters would be outside of the machine. Then you would run the product supply tube through the RTP into your surge vessel or directed to the filling needles, depending on the design. Okay. We also have open isolators. So very similar to closed, it would just be there's no sterilization of the components as they enter, and then it would have small openings for the in-feed and out-feed to a lower grade area. So inside the isolator would be grade A. Directly outside would be maybe grade C with grade A air supply. So we would have, laminar flow just right outside every opening to the isolator. So for this, generally open isolators use pre-sterilized, ready-to-use components. So this would be the vials that come in tubs and bags. So the bag removal, the second bag removal, and then the tub would transfer into the grade A critical zone, peel the lid off, seal and seal, transfer out, and then transfer directly to a capping machine for a non-lyo product. So these openings here are what are referred to as mouse holes. Generally, those are sealed during they have to be sealed during the decontamination cycle, and then they're opened once you maintain positive pressure inside, so that air is always cascading outside of the grade A zone. So here's a picture you can see. So right here is the tub, and it will be pushed into the mouse hole, which is this guy. So the blue arrow represents the airflow, which would always be flowing out, and then the red would be the components that would be going in. So this tub would be, sterilized by the supplier and then delivered and transferred to the filling machine. So these mouse holes are designed very specifically to be as small as possible because we need to maintain the positive pressure inside the isolator and ensure that airflow is always flowing out. So it can't be too big, otherwise you have to run the isolator at a much higher rate to ensure the positive pressure stays. So these will be very dependent on, obviously, the components that you're using in that machine. So I know that was kind of fast through all that, and apologies for that, but I wanted to make sure we got to this section and then also to the questions at the end. So we can always go back to anything if you guys want to look at it in detail, but now let's take a look at the future of aseptic filling. So there's a few things, few things we'll talk about. The first one is blow, fill, seal, BFS. It's actually quite old. It's introduced more than 40 years ago, but recently it's becoming an advanced aseptic processing. The FDA has indicated that it is the preferred technology going forward. So if the product can handle being filled with a BFS system, then you should definitely look into it. So the BFS at a high level is very different than a RABS or an isolator. It's a completely contained system where plastic containers are blow molded, filled with liquid, and sealed in one continuous operation under aseptic processing conditions. So it's a completely automated system with little to no operator interface or interaction, sorry. The critical zone is very much reduced in size, and it minimizes the exposure of products to the external environment. We'll take a look at that. It's difficult to explain if you've never seen one, but we have a video here. So the BFS system consists of basically the mold and the mandrel, and then the container itself. So step one is extruded. So plastic pellets are melted, and then that plastic is extruded down into the mold. The mold then closes to form the container. So generally there's some vacuum that goes on to ensure the mold expands to the full size of the mold, sorry. And then you have filling. So the needle is inside of the container itself already. So then you fill, then the needle is extracted, and then it's sealed, and then demolding. So all that occurs in a continuous motion with very little interaction with the external environment outside of your plastic tube extrusion, and a very, very small critical zone as well. So maybe to help that out, I have a let me see. Here we go. Yeah. Make sure this works. Okay. So this is a Romalag blow-fill seal machine. I think there's many suppliers in the market. Romalag, I think, is one of the biggest. So it looks nothing like a typical filling line here. And as we get inside to the critical zone, so the yellow bits are the mold, and then you can see this is actually the needle here, or the mandrel as it's called here. So as the plastic is extruded, it's into the mold, and then the liquid is filled into the mold and sealed all in one continuous motion. So there's no vials, no stoppers, no caps, and then it's all done with the plastic extrusion. And there's very little exposure to the external environment, which is one of the benefits of BFS. There's a lot of downstream machines as far as you can. They have the cutters. They can label them, visually inspect them. There's a lot of downstream machines that can be installed after the filling. Yep. Okay. Yeah. So this video is on YouTube. So if you guys want to check it out, you can just go to YouTube and type in Romalag, and it'll be one of the first ones that come up. But we'll move on to the next type here. Oh, sorry. Oh, sorry. There you go. So the next system we'll look at are gloveless isolators. So again, very different than BFS. They're similar to the type of isolators that we're all familiar with, except there are no glove ports. So once the internal environment is sterilized, there is no operator interaction with the process at this time, other than via the HMI. So these are becoming very popular for small, flexible batches, i.e. gene therapies. They're very programmable and they're very flexible as far as the process that can be performed. So again, gloveless isolators can be installed in grade C or D backgrounds, and they use internal robotics to manipulate the process, which typically are not seen in conventional isolators. So I have another video here. So this isn't a filling machine, but it's the same idea. This would be a bulk powder machine here. So let me see if I can play this. I can't get my laser.
This is nice to see.
Is that Simone? Here we go. Sorry. So this is a video that Fedigari has given us. Thanks, Simone. So here, again, fully closed system, no glove ports, no interaction from the operator once the environment is in the sterile state. So again, this is a powder filling process. So, but the same principles apply to an aseptic filling. So these robots are capable of all manipulations inside the critical zone. What is that? 1, 2, 3, 4. Is that an 8-axis robot, Simone? I'm not sure. Yep. So the isolator would be designed with, however many of the robotic arms are required to perform the filling and sealing of the product itself. So Again, these machines would be very tailored, very customized to your product and process. So you have to have a very, very good product description, before going on with design and manufacture of these type of machines. Okay. Move on from there. Okay, so kind of coming to the end here. So in order to control the risk, we need to increase the degree of separation from the operator to the process. So moving from open bench tops to isolators, to BFS, to gloveless isolators, the common denominator across all of that is we're taking the operator and just pushing them one step back away from the critical zone every time we take a step up this ladder here. Also, the size of the critical zone has been decreasing in size. So you don't need an entire room of grade A HEPA coverage. We can use an isolator, a very small isolator, set it in a grade C, a grade D background. Much easier for operations, much easier for maintenance, much easier for quality. It creates a lot of benefits the smaller we make the critical zone for these machines. With the insurgence of like single-use components and just single-use disposable components, that really makes machines like isolators or even gloveless isolators very beneficial, as there's no washing, no cleaning validation. You use it once, throw it away, and then you're done. So all of this leads to a much higher sterility assurance during batch processing. So just to follow or end up here. So in the past, the process or the operators were reacting to events in the process, and that would lead to interventions. Today, we're trying to manage the risk and reduce the events. So again, risk is equal to probability times severity. For aseptic filling, severity is always equal to high. So we have to reduce the likelihood of the events. So that's what we're looking at currently. And then taking that step into the future, we want to remove the probability of these events occurring. So that would be, again, removing the operator from the process to ensure there is no microcontamination from the operator themselves. So that's the end of my presentation there. So I got a lot of questions on the klaxoon, and I think there's quite a few questions in the chat as well. So let me pull that up really quick, and then we can have a discussion. Okay, can you guys see the klaxoon page?
Yes.
Okay, cool. Okay, let's take a look at our polls here. We got, okay, so most people have experience with filling lines. Quite a few, not too many votes, but that's all right. And then, yeah, lots of people with isolators, RABs, low fill seal. Okay, cool. All right. Okay, so let's take a look at some of the questions. So first question, when it comes to aseptic manufacture, could you touch upon pros and cons and industry norms regarding continuous manufacturing versus non? Continuous manufacturing, that's a big one. So in my experience in pharmaceuticals, I've never really seen a continuous manufacturing process when it comes to the filling and packaging side. Especially when we're talking about isolators now. You perform the decontamination, then you have to validate how long your isolator will stay in a sterile state after that decontamination cycle. So you have to split up your process into batches. If it's sterile for 5 days, then you can operate for that period of time. It just depends how you approach the qualification and then approach your business plan as well, as far as how big of batches do you want, smaller batches, how long will it take to fill and complete. Yeah, so as far as for the downstream processing, I don't really know of anybody doing continuous manufacturing for filling. Maybe it's out there, I'm not sure. So whoever wrote that, I don't know if you can unmute and then we can discuss if you'd like, or we can move on. So somebody posted in the chat here, continuous aseptic manufacturing typically using aseptic beverage. Okay, I'm not familiar with aseptic beverage on that one, so.
Can I ask?
Yes, and Chan has just joined me here as well, so I think
So just follow up on that question. Aseptic, if you do continuous, normally at the end of the batch, right, we do active air sampler. We don't want to do that in between the batch because that will interact your airflow. So we do it at the beginning of the batch, at the end of the batch. Just curious, if you do continuous, when do you do the active air sampling?
that's a good point, yes. Okay, we can take a look at the next one here. What are the common pitfalls in designing isolators? I'm sure there's quite a few. So the biggest thing when it comes to designing a filling machine of any type, whether it's a RABS, isolator, whatever we're talking about, is you have, before you get into the design stage, you really need to have a very good understanding of your product and process. If you know your product and you know your process 100%, then you can work with one of the many isolator vendors, and they can help you to design an isolator that fits your product and process very well. If you have a poorly defined product definition or process, then it is very difficult to ensure the isolator will meet your needs as far as you know, the output required by the isolator, the weighing interval, the IPC interval, the active micro samples, the particle counters, everything has to be taken into consideration when you're in the design stage. So it's not only an engineering endeavor, you have to involve the users, manufacturing has to be involved, quality has to be involved, you know, your validation department, everybody has to be involved in this design. So that's what I would say is the most common pitfall in specifying any new machine would just be you need to ensure you spec it correctly before you get into design.
Remember that one we had in the past?
Yes.
It's actually RABs, but when they designed the RABs, right, and they wanted to cut some holes and windows for the operator to actually access the filling line, but then unfortunately, when they designed the RABs, the filling line and the operation wasn't in place. So the whole the window was totally out of nowhere.
Yes,
you
exactly.
can't access the filling line through the design. So I think like you probably want to understand where you want to access the filling and what kind of operation you need to have, and then makes sense to do a quality risk assessment before that.
Yes, definitely. That's a great point. The quality risk assessments have to be in place early on in the design phase, because that could impact the design of the machine itself, whether it's the RABs with additional glove ports or additional sampling airheads or particle counters. That all has to be evaluated and assessed and then agreed upon in the final design. Okay, let me see here. Okay, so we talked about that one. We talked about that one. Is SIP for needles mandatory for filling line machines? So sterilization is mandatory. How you sterilize can be up to interpretation. Typically for the filling needles, I would expect these to be more of an autoclave item. They would be, you know, assembled in your component prep room. The tubings and everything would be assembled as much as it can be, and then it would be placed into a bag or an RTP container, thrown in the autoclave and sterilized via the autoclave sterilization. I don't know much about SIP for needles. If it's in place on the machine and you want to do an SIP, that seems possible. I think you would definitely need to have specially designed equipment for that. But I think high level, your needles have to be sterilized before starting.
Yeah, question is mine, Graham. And I mean that once you install the needles, through a flow-through steam to sterilize them, or is enough sterilize an autoclave in a double bag and then open the bags inside the isolator? this is because I've seen one time that once they install the needle, then flow through steam in order to sterilize. But
Okay.
many other doesn't. So many other just sterilize in the autoclave with double wrapping, and then install the needle under laminar flow. I'm just worried about that there is a risk of particle distribution if I open a bag into isolator, maybe.
Yes, yeah, and that's, I mean, and that's
Maybe.
definitely, I think, kind of as the industry is trending that way, is, I mean, definitely during the qualification, validation, you have to prove that the interior temperature within that needle reaches whatever your criteria is for sterilization for your time and temperature. So during the validation, you would have to use thermocouples inside the needles to ensure it does meet that requirements. But yeah, one of the things you brought up with is particle generation as you are installing not just needles, but other like stopper bowls, stopper tracks, all that type of stuff that generally comes out of an autoclave, wrapped in Tyvek paper. So that is something that I think everyone is dealing with, and I think the best solution hasn't really been found yet. There's always ways to debag kind of as you transition into the isolator, maybe not outside the isolator, but not inside the isolator. Again, it's kind of a gray area on that. But yeah, the particle generation is a concern. And then as far as SIP in the needles after installation, I think that's another assurance that you can get that there are no particles in the interior surface of your needles are sterilized. But again, that's a very big kind of capital investment, I would say, for that. And depending on your machine size and number of needles and all that type of stuff, is it worth it? You know, all that would have to be evaluated via quality risk assessment. But I've actually never seen an SIP of needles after they've installed. That would be interesting. Okay. Sorry, let me just get a little.
Thank you for answering me.
Thanks for the question. Okay. Lyos can be sterilized with steam. Isolator can only decant THP. Any risk of cross contamination since the two processes are different. Yeah, for this one,
it's me again.
Okay.
You know, the two processes are quite different because decontaminate is surface decontamination, and log reduction is not really mandatory to reach the 12-hour reduction as a sterilization. So I'm just knowing myself if the filling line can be risk of contamination of the Lyo because the door put in place the two ambient Lyo chamber and filling line.
Yeah.
Maybe the risk is really little, really small, but maybe there is something that can be put in risk
sure.
our process.
Yeah, for sure. I mean, and I think it could be they're sterilized separately, and then there's another sort of sterilization happens that as they're integrated into one another, something occurs there. To be honest, I don't really have a good answer on this one. But yeah, I think that's definitely a risk. It's kind of the same thing when you look at the RTP canister. You know how the canister is sterilized outside the line. The interior of the line is decontaminated, and then there's the interface with the door that both sides are sterilized, but when you open the door, how do we ensure that the seal, the edge, that everything is sterilized or sterile as well? But yeah, I think that's definitely a place that needs to be investigated. Again, I don't have the answer. Your questions are too difficult for me.
No, Simone, you remember we had a machine in the past, and that was designed by Filigari actually, and the URS was partially created by Filigari as well, because user had this requirement. They have two machines connected together, and both equipment need to be sterilized before you open the gate in between. And that's kind of saying, like we always say, your equipment supplier is an extension to your manufacturing floor. And if you have this kind of request, and talk to your supplier and see what kind of solution they have And back then, that machine is integrated together, and I think there's some interlock in between. Simone, if you remember, and you have to check the status of sterilization on both ends, and then you open the gate in between.
I think it was an autoclave was an autoclave connected to Isolator, sterility test cabinet. Yeah, makes sense. But the flow was in one way. So from the autoclave, so my higher grade of sterilization, the door was opening to a lower grade, let me say, that is decontamination. So, and the process was just in that way. If imagine a layer that face to an isolator, imagine that you fill in the layer, and from your isolator, something can go inside. And the other side, in our machine, with the flow was from autoclave to the isolator, autoclave isolator, autoclave isolator. So my load was sterilized, and then when I open inside the isolator, I had a higher grade of sterilization. But this is just very remote to happen, in my opinion, but can be interesting discussion for another Technical Tuesday sometime.
Yeah, I think we could have an entire.
I miss you all. Let me say this.
Yeah, I think we can actually look at this topic and do a contamination control strategy, and look at the process flow and see what point can be our weak points, and put some control measure around that point.
Yeah.
Okay. Oh, we just got notification, Linda. So we're kind of running out of time here. I'll try to get it for a few more questions. I'm okay to stay on a little bit longer. If you guys want to stay on maybe 5-10 minutes extra, we can go through the rest of the questions. If you have to drop off, you can drop off. Thank you for attending, but we can stay on as long as you guys wish, really.
Okay. Well, you want me to answer the contamination control strategy?
Which one is that one? The green one?
The green one.
Yeah, we can.
That's my favorite topic.
Yes,
really. We do have an experience example. Actually, we set up the SOP for that. I think a lot of the companies are trying to implement this new requirement. Actually, a lot of companies already have. And when like all the quality QP background people talk together, and it is based on your risk assessment, and contamination control strategy for me, it's really an overarching document. It will look at all the risk assessment done in the past and summarize where your risk, high risks are, and then you will need to have this plan. Do you have a reason? Do you need to remediate any reason and put that kind of how do I say? No, what's the word I'm looking for? You will need to have different hierarchy, and you target on the high risk one first. And of course, well, I think you all have loads of risk assessment. It's just nobody is really using them. And contamination control strategy is really, really a good starting point. You start using all the risk assessment you done in the past. And this kind of thing, you always need to review. And my preference is review on an annual basis. And when you do your annual product quality review, and then you also look at your risk and anything changed. Because when you do your quality review, you review the change control, you review the deviation, what all has happened in the past. So it gives you very, very good input to update your contamination control strategy. So it again will be a long discussion. It's just on high level. Yeah, and I know different companies are doing it differently. If you look at new Annex 1, it gives you a list of things you need to touch on. And it's a very good starting point for you if you're thinking of implementing one.
Okay. Okay, I can hit a couple of these over here. So for this one, transporting sterile and sealed rubber stoppers from the porous load autoclave to the filling machine via grade CD room certainly would pose a risk. What are some mitigation strategies typically adopted? So a few questions would be, what type of filling machine are we dealing with? How do you add these stoppers to the machine? Is this an RTP transfer or more of an open door transfer, like a dumping a bag out? There's lots of strategies to transfer sterilized items from like a centralized autoclave to maybe there's 3 or 4 filling machines that all use the same few autoclaves to transfer sterile equipment into it. So There's always double bag, triple bag, laminar flow carts, laminar flow hoods that you can transfer from one room to another. And then, once you're under your grade A environment, near to or at the filling machine, you can remove the bag of stoppers, remove the exterior bag as you transfer it into its location, and then do the addition of stoppers to your stopper hopper. The best way for this is make this an RTP transfer. So they have bags with integrated RTP ports. They're single-use bags. They're plastic RTP ports. You can sterilize the entire bag, transfer it to the filling machine, connect it to the opposite port on the filling machine, open it from the inside using the glove port, and then top up your stopper hopper that way. That would be the easiest way and the best way to make that more of a robust transfer. Okay, so this one I can also hit here. How risky is to design isolator process within a grade D background? Wondering this is in practice already. I believe it is. For me, the background for an isolator doesn't really matter. Most of the isolators designed today are very robust and they're very self-contained. You have to be very careful around the mouse holes. If it is, an open mouse hole for the in-feed, out-feed, and then, if there's a waste or anything that comes out for the empty tubs or empty trays, you do need to be very careful about the type of air supply that is on the outside of those mouse holes. You have to ensure that is grade A supply on those mouse holes for a specific area. And you also have to ensure your isolator maintains positive pressure to the background. So all that would be your smoke studies, your qualification, and then monitored within the isolator itself.
I think it's more for the frame.
Sorry?
Aseptic cream filling. You can have
cream.
Cream.
Yeah. I think it doesn't really matter as long as there is, again, going back to the risk assessment, you would have to perform a risk assessment and your quality team would have to accept that you have a grade A environment with a grade D background, and then you would have to explain that the openings from the isolator to the background are covered with laminar flow for X, square meters or whatever on the outside, and that flow is unidirectional out of the isolator with the positive pressure that is maintained and charted and audit trailed for the isolator itself. Okay, there's a lot of questions in the chat here.
I think Linda wants to close this one. Why don't we transfer all these questions to the board so you can still have the access to the board? We answer those questions. If you want to leave your email, we can email you with the answers.
Yeah, can. Cool. Okay, so I'll copy a few over. Can't do that.
Once we close the meeting, we lose that, right? That's what we need to.
If you see one, you can handle.
Yeah, this one, when you copy over, I just quickly answer the supplier risk assessment. So of course, supplier qualification is part of your quality system. Every site will need to have, and DS side and DP side doesn't matter. And first thing you would look at is the material or service they're providing. How risky is that to your product quality, hence the patient safety? And then you also need to consider the history with them. Did they have any GMP certificate, ISO certificate, this kind of certification thing? And then how many OS they had with you in the past or stuff. So it's an overall scoring. It's not just looking at the risk. And then based on the overall scoring, you look at high, medium, low risk. And for the high risk one, it's recommended that you do a site audits on their side. And the low risk one, you just give them a questionnaire. And then every 2-3 years, and depending on your quality system, you need to revisit that questionnaire or audit. Because during those 2-3 years or every year you review their score, and there might be change in their performance. There might be change in the risk you see of their material to your product quality. So it's an ongoing effort, really. And of course, if you have a material review board, if you meet monthly or quarterly, you review the performance of your supplier and vendor, and any issue they have, the trending will be reviewed in those meetings as well. Good, then.
Okay. All right, so we can maybe talk about this one.
Yeah.
Can we use only wash vials directly for filling in terminal sterilized products? In glass vials, washing is controlled with filters. Yeah, so for the incoming components, you can do washed on site, sterilized on site. You can purchase ready to use, ready to sterilize. There's a million different options when it comes to the type of components that you can use. You just have to, again, you have to spec this in your design because the equipment used is very different if you're using ready to use components compared to ready to sterilize components and things like that. So you just have to know what you want to use, and then you can find a vendor who can supply the filling line and upstream equipment for the component transport or for the component washing and sterilization as well.
Yeah. For this one, if you just wash with VP, I wouldn't recommend because you need to take care of the endotoxin as well.
Oh, I missed that part.
Yeah. Yep. Final sterilization depends on the temperature. For endotoxin, you need to incinerate it. Not 121 wouldn't help you. You need to 230 degrees C, right? Yeah. I think the tunnel was 230 degrees C, 300. Mm-hmm. So for endotoxin, this one it doesn't work.
Yep.
Should we leave the next time?
I think so. To be honest, I don't know if I could answer too many of the other questions. They seem to be outside of my knowledge bank here. But we can try to answer these and maybe email out.
Yeah. So just maybe show the Gus's email here. And if you have questions, burning questions, email Gus and we'll help him to answer.
I've put the email in the chat as well.
Okay, cool. Thank you so much, Linda.
Yeah. And we do have a recording of all the questions that have been submitted, and we know, I think, pretty much everyone who's on here and their email addresses. So we'll exchange that with you.
Thank you so much.
Yeah, and I think for a lot of these sterilization questions, definitely reach out to Simone. He is way more of an expert when it comes to autoclave sterilization, steam sterilization than any of us on this side. So I'm sure he'd be more than happy to answer your questions.
Thank you. And Simone, can you just input your email address in the chat, please, while I remind everyone that we will be posting a copy of this recording on the ISPE Singapore YouTube pages. And so again, on the chat, you can see the link to that. Thank you, Simone, for putting your email in there. And also there was a question about showing the links for the videos. So again, I think the Fedegari video, is that on YouTube?
I believe the Fedegari one was not on YouTube. I think Simone hooked us up with that one. The Romalog one is on YouTube. You can just go to YouTube and type in Romalog. For the Fedegari one, I'm not sure on that one. Okay. We'd have to double check.
Yeah. Well, then you can email Simone or you can email Gus, and you've got their details there. But thank you all for your questions. Seems like we've got some good content for another session to follow up, probably early next year. So thank you everybody for your attention this evening, and thank you Gus, Shanshan, Simone for joining us and
thank you
for your expertise with us.
Thanks to everybody. Ciao Shanshan, ciao Linda.
Have a great evening.
You too.
Ciao. Bye.
Ciao. Bye.
Thank you. Bye.